Yeah. Hello, everyone. Good day. This is Jamal, and in this video, we'll be talking about some results I've had on the perfect cuboid problem, which is an open problem. There have been a lot of claims that perfect cuboids do not exist, but there have not been any accepted, well-recognized proof. And in our modern day and age, with the modern AI world we live in, I'm aware of relationships of trying to intersect AI and mathematics. And I'm aware of, you know, AI-assisted proofs. And a bit of a backstory is the story of the four-color theorem, which is an open problem which was solved in the mid 70s. So I would share my screen, give a brief story. Okay, let me share. And so, let me see. Yeah. So I'm going to show us a bit of that problem I'm talking to you about. So this is the problem, the four color theorem. So this is the problem I was talking to you about. So, you know, it is just something of by the way, just for a bit of context. Yeah, as to, and this was one of the early examples of AI used in solving a problem in mathematics, an open problem. And so I've had my own results on the perfect cuboid problem, and I'll be very modest about the claims I make. It's still they're still it's still these are still partial results I have on the problem. So this is a bit of context into what the perfect cuboid problem is. So this is the perfect cuboid problem. This is a bit of Wikipedia work we are doing over here. So I'll just this is a bit of context. This it's a box. This is the box here, which is defined by these equations. It's a set of four equations. This, this, and the last one. Uh, and this is the last one, you know. And so I spent this last few months trying to work on this problem. I wrote a first preprint on share, which is over here. This is a previous paper. This is a previous paper. So when you go here, this was my first work on perfect cuboids, you know, which which I've since gone on to update my results. There have been four different versions so far. But at the moment, I've been able to, write a different paper still on this same problem, but trying to improve my results. So at the moment, I have a proof, some partial results, and I'm trying to look out which gaps do I have to fill, which gaps do I have to fill. But given that this is an open problem, I would reason that I'm not going to guarantee that I'm going to solve this today or tomorrow, but this is mostly like a long-term project. So let's say it could be, some months, a year or two, I don't know, but yeah, we're trying to work towards it. And I'm putting this my video out there, for to welcome feedback, ideas, what I couldn't have accounted for, how best to approach this problem. I'm taking in all feedbacks, because this is something I'm just trying. So um this is I would go to GitHub. Let me see. Okay, GitHub. So so this was my recent update. This is my recent update on perfect cuboids here. And I think in the comment section, once I'm done with this, I'll attach it to the description section of the channel. So this is the PDF, which is still undergoing updates once in a while. So this is it. This uh, initially even this paper I wrote was intended to be a summary, like maybe a three summary paper capturing the essence of my previous work I showed you earlier. But as time went on, I began this paper now developed into some sort of improvement of my previous paper, which I think I like my modern version than what I wrote months before. So This is what I've been able to do. This is the system of equations I was talking about. We define a perfect cuboid. So here, this is it. This is on my GitHub. Like I said, I'll put a link in my description section. This is all of that. And these are some codes. Yeah, yeah. So I've attempted, actually, I'm still learning Lean, which is a proof assistant, which I normally use to prove. Nowadays and age now, whenever you claim to prove something, it makes sense to run it through a proof assistant, which I'm still learning. I've only watched a few YouTube videos, you know. And so as time goes on, as I'm still learning, I'm also trying things out. For now, what I would normally do sometimes, I put my own PDF, like I've shown, which is my own core work, into a proof assistant like Claude AI or DeepSeek, and I get it to rate my work on a scale of 0 to 10, and I get feedback, my strengths and points of improvement, and then based on that, I try to improve my work every single time. You know. So right now, this video, I'll just share my updates, what I've been able to do. Maybe in the coming videos, I would share my, you know, we'll delve into this problem, try to recognize ways of filling gaps where needed. So, uh, yes, let me check something. I'm gonna do check something. Yeah. So this proof, this lean codes, uh, they were deduced by VS Code, which is here. This I had run a series of chats. So this was my proof on VS Code, but I think I've reached my limit here. So yeah, see, show chats. Let's see, open chat. Let's see. Oh, there were some things I did before, but whatever. I'll share it with you. I had some series of questions I posed on this, the ways of accessing my previous chats. Mm, some previous. No, let me see this show chats. Okay, yeah, I think I've seen it. Yeah. So this were a series of chats correspondences I had through Copilot on JIT on the VS Code. So I'm going to scroll to the very first point. So I asked it to formalize a proof for me. It ran some proofs. This, all of that. It ran us through this, you know. So all of these things, all of this information, it even suggested a whole sort of complete formalization, which is a template for now, which I intend to build on the course of time. This was the template it built. So yeah, this was the template it built. Yeah. And so based on those templates, I would show you where I put it on GitHub. I put it on GitHub. So, mm, so this was my perfect cuboid proof. So this was where I first shared. Okay, no, I think this was even from Claude AI. This one. No. Oh. You think it came from somewhere? Yeah, this was I think this should be one of them. I don't know. Let me see. Oops. This is basically just me doing stuff. I'm just putting my own work out there. This, yeah, yeah. I think this should be. Yeah, this is it. This is it. This is it actually. Look at me. I'm just a bit. So so it's all over. Oh, like I said, this will go to my description section. So these are some of the proofs. So which There are some sorry commands. And these sorry commands like this you see, like this you see, they don't necessarily mean that the proof is wrong, but it only tells you there are gaps that have to be filled. So right now, my only in the series of number of videos, my strategy now, because I'm just trying to make up for the knowledge gaps with this sort of proof assistant. So what I normally do is when I put my own PDF in one AI model, I get it to return proof like lean codes. So when there are gaps like that, the idea would be to to take one section, one lemma, or a corollary where there are these kind of gaps. Then I put it into a different AI model. I attach it to my PDF work, and I'm like, this the lemma that I have. This is where it comes from. Why do these gaps exist, and how do I fill it? Sort of AI assisted sort of proving I'm trying. And honestly, my idea of taking a idea of AI assisted proofs a bit seriously is inspired by an online seminar I attended last year, September, organized by the Pacific Institute of Mathematical Sciences on AI and mathematics. I think Terry Tao gave a very great lecture there. Yeah, I think I attended that one. It was a nice one. I think he also has some nice videos on YouTube too. I found them on YouTube. Let me see whether I can Google them. Let me see. Uh, machine assisted proofs. Yeah, I think these are some suggestions. I think Terence Tao has great videos there. So this is a recent video of his. You can see, yeah. So actually that seminar he gave was not very different from these lectures you see, but they were very helpful. I had a recent correspondence with a professor, a number theorist at University of Leicester. He gives me feedbacks, suggests tools I can use like Lead to formalize these proofs. And that was the second time I'd heard of this sort of language proof assistant since what attending these programs. So that also partly inspired this sort of idea of trying things on my own, in my own way. I'm not talking bigger than myself, so I'm just putting things out there. Definitely, there are much people who are much more into these things more than me. I'll gladly get feedbacks. My goal would have been to solve this particular open problem. I've been able to work it out to my physical limit, trying to get AI assistance with formalizing my work properly. At least I'm just trying stuff. So if there's also anyone out there with also new ideas, I will take it. I will take it. I think even on my own fixed share papers, preprints I've left, but they have my emails and stuff you can access to if you think there's some new ideas you can bring out of that with anything interesting. So I'm just putting things out there. So this is just by the way. And so I'm gonna show you some results I've had. I even tried asking questions on ChatGPT, just trying stuff, and was able to suggest certain ideas which at my level of experience, I'm not very familiar with the idea of two-adic numbers, p-adic numbers. I've heard of them before, but I've not had the experience full time because I'm not a formal math student, please. But I've learned stuff. So I'm trying things and let me see. I'll share some of, I think I will share the link of my ChatGPT correspondence, also in the link in the comment section. So in the description section, yeah. Let me check something. Uh, let me see. I'm trying something on my ChatGPT on my phone. Let me see something. Let me see. Okay, it's even here. Yep. Okay. So I think it's loading. Yeah. This correspondence with ChatGPT is a whole list. It's a whole long stuffs. You know, these are lean codes ChatGPT suggested. And in fact, in the last lean codes ChatGPT suggested, it was very great because I did not say, hey, ChatGPT, solve this for me. I put my PDF, my own efforts into it, and I got to recognize gaps. What separates this from my complete proof? How I could account for those gaps, how I could fill them. It suggested nice stuff. So I'm scrolling to the beginning of the correspondence. So this was the document, which is not different from what I showed you earlier on GitHub. Yeah, and so this is it. So it mentions this stuff. It rated my work 6.5 out of 10, And these are the things such as suggestions it gave. These are further suggestions. It's a whole long sort of stuff. So I'll be open enough to put this on the description section of this video once it lands on YouTube. Yeah, I'm just trying stuff, trying. To see, So I think I told you about two addict mismatches, whatever. Some of these things I don't understand them. For instance, two addict. I'm learning those things still. All of these things, all of these ideas you see are based on my own work in my paper. Which, if you check on my GitHub, you find these things I did in my paper. You know. So this is it, and so this was the proof based on ChatGPT suggested this. So you would find out that there are no sorry commands. There are no sorry commands which tell you that something good is happening. But at the same time, I'll not be so quick to call my shot. Okay, there's a little sorry over here. Hmm. But it's open. I'm taking feedbacks, ideas, whatever. Once it leads to a solution to the problem, great. This some efforts too out there. So um yeah, so this is what I've been able to do so far. Yeah, I think I'm sharing my results over here. These are some things. I remember recently asking a question on a Zolip, which is an online community for Lean. So would Google some stuffs and see. Let's see. So this is Zolip. This is supposed to be a public chat with regards to lean formalizations over here. Yeah, but I do think that I want to put mine out there, you know, getting my public. And uh, I recently asked a question here I was trying to talk to you about, but in the feedback I got, sure, it tells that there's still a lot of gaps to fill with my experience on lean, you know. Uh, but I mean, I do think the improvement to be made on my paper, on my lean codes, especially with regards to these math lib lists or library, whatever they call them, imports something. If there are new ideas, or Jamal, these are the sort of imports preambles you should use instead of these. I'll take all sort of feedbacks. If there's any way of even working with people for this to lead to a complete acceptable proof, I'll gladly take it. So I'm just putting things out there, putting in a measured effort of mine to attempt this problem to work, attach to my best and see, And so this is just me putting things out there. I don't think I'm going to go into too much detail in this video. This is some sort of an introductory video somehow. Yeah, this is a weird way to introduce a video, but this is it. So yeah, you know. But like I said, I'll share all possible updates on the description section. So these are the codes, um, and I leave this here. And I'll welcome all sort of constructive feedbacks, especially the feedbacks, are great feedbacks. One even feedbacks will lead to new insights on how to attack this problem, how to make further contributions to this problem. It's a good thing, no problem. So I'm putting this out there. So I think this is where this video comes to an end. It's just me saying stuff. So this is my first video. This is gonna be my first video on YouTube, and it's gonna and I think I understand it will sound a lot. It will sound very technical for first time people watching Jamal on the YouTube channel. But as long as we're getting somewhere, so I'll leave this here for now. So I think I'll end things here for now. And so thanks for your time and thanks for watching. So yeah, bye. Au revoir. So.